have come to DE due to the loop at the point P, correct?
Yes, sir.
So we have come to that. We haven't substituted our limits of Z.
Yes, sir.
Now, here I will have two cases to discuss. That's why I stopped over there. So case 1 is if point P is inside the sphere. If P is inside sphere, if point P is inside sphere, how will the figure look like? Same sphere, okay. The row was open for a long time. Same sphere, okay. All my circles are egg-shaped. Okay, so same sphere, basically same loop also.
Yes, sir.
I'm not drawing the loop right now. Let us say my point P is somewhere over here.
Yes,
Okay,
sir.
and my center is O.
Yes, sir.
If my loop is here, that means Z is this. I'm interested in Z because I'm interested in the limits of Z.
Yes, sir.
One another thing, the distance from O to P is R.
Yes, sir.
Distance from O to P is R.
Yes, sir.
And I'm interested in what? Limits of Z. We
Yes,
already
sir.
know how can I make this hollow sphere by bangles of different radii,
Yes, sir.
starting from rightmost point to the leftmost point.
Yes, sir.
Is this clear?
Yes, sir.
So for point P inside, what will the limits of Z be? Starting from the rightmost point to the leftmost point. What will the limits of Z?
Minus R to R. Or we can take 0 to R.
In this case, I can say it is R plus R to R minus R. I said starting from this point. When your element is this point, what is the distance? What is the value of Z? Z also becomes a horizontal line.
Yes, sir.
When your element has come to this point, Z also has become your horizontal.
Horizontal.
What is the length of Z in that situation? R plus capital R.
Yes, sir. Yes, sir.
And what is the Z value at the leftmost position? Capital R minus small r.
Yes, sir.
So I can take the limits as capital R minus small r to capital R plus small r, or capital R plus small r to capital R minus. Did you understand the limits of Z?
Yes, sir.
Because Z itself will become a horizontal line when the element is at the boundary condition.
Yes, sir.
Rest mathematics will take care. And we will also prove that mathematics will take care. But is the values of Z clear?
Yes, sir.
So for point P inside the sphere, my electric field at point P resultant will be integral of this story, right? So
With
basically
limits
with
R
limit
minus R naught.
4r square, capital R square. Is it capital R square or is it only capital R? Check it once. I think it is R square.
R square.
Okay. So limits, what do we want to write limits as capital? Can I write it as capital R minus R to capital R plus R?
Yes, sir.
Okay, only difference is minus sign. I'll explain the integral parts after this derivation. Okay, and what do I have remaining? I have 1 plus R square minus capital R square divided by Z square dz. Fine.
Yes, sir.
This in itself also has solving. I would not rate it as a difficulty, but as a student initially, you will feel as if this is something big that I'm doing right now. Okay, should I erase this also?
Yes, sir.
Okay, express train activated. Take a look. So I have constant kq by 4r square r square. After integration, 1 will become z.
Yes, sir.
Integral of dz by z square is minus 1 by z.
Yes, sir.
Minus, I have r square minus capital R square as a constant in the numerator divided by z. Limits from r plus r to,
And did you take
sorry,
Z minus?
r minus r to r plus r. Yeah, tell me.
Isn't it Z plus?
I have a plus over here. I will
Yeah.
get a minus sign due to the integration.
Yes, sir. If you take that inside, then you have to do R capital R minus small r.
R square, we can write it like that also. So let us write it like that also. K capital Q by 4, there is a square over here. 4r square capital R square. First term, limits, upper limit minus lower limit.
Yes, sir.
R plus R minus R minus R will give me 2R.
Yes, sir.
Fast mode. Is it clear?
Yes, sir.
Or do you want me to write the detail?
No, right, sir.
Right? So this is fine. For the next one, I will write it in detail. Do you want me to make it plus? It will become easier.
Yes, sir.
So I have r square minus r square in the numerator divided by upper limit is r plus r minus again r square minus r square in the numerator and lower limit is r minus r. Now I think you can see why I rewrote it. I wrote it in detail way. A square minus b square, a square minus b square, and here I have a plus b and a minus b.
Yes, sir.
So basically, one r plus r will cancel, r minus r will remain here. Yeah.
Yes, sir.
So again, close the bracket. Again, starting k q by 4r square capital R square into 2r plus in bracket I have r minus r, right?
Yes, sir.
Minus, I am putting a bracket for this story, a square minus b square by a minus b. I'll have a plus b.
Yes, sir.
Is this clear?
Yes, sir.
Close of this bracket, close of this bracket.
Yes, sir.
Just a human intervention over here. What should the electric field by geometrical sense inside the hollow sphere be? why I am doing human intervention, I'll explain. This is my hollow sphere.
Yes, sir.
If I am anywhere, let us say somewhere over here inside the hollow sphere, and everywhere uniform hollow sphere of charge, capital Q, right?
Yes, sir.
And uniform charge distribution everywhere. The electric field due to the points which are the charges which are closer to point P will have a greater magnitude in the opposite direction.
Yes, sir.
The electric fields which are farther to P will have lesser magnitude but will have more number of charges. There are more points which are far from P compared to the points which are closer to P.
Yes, sir.
The points which are closer to P might come from here to here, but the points which are farther from P will come from here.
Yes, sir.
There's a very important statement that I'll make right now. Continuous integration of a vector. Continuous integration means addition. So addition of a vector which is varying continuously, continuity in the mathematical sense of calculus. Function is continuous.
Yes, sir.
You know the condition for continuity, right? The continuous integration of a vector will result to 0 if the vector begins and ends to the same point. I am integrating, let us say the electric field due to this charge is some E1.
Yes, sir.
As I am moving, let us say I am moving in an anti-clockwise direction. This I am explaining to you in a understandable way. Mostly this should be stored in the imagination part of your head. Okay.
Yes, sir.
Let the electric field due to this point be E1. As
Yes,
the
sir.
point is moving, for example, let us say this is a wire, okay. So as the point is moving in the anti-clockwise direction, the electric field due to each and every point will be E2, E3, E4, E5, E6, E7, E8, E8, right? The magnitude of the electric field from E1 to E2 to E3 to E4 is a continuous variation.
Yes, sir.
The integration of a continuous variation in a closed path. So what is this vector doing? It is rotating in a 360 degree.
Yes, sir.
Ultimately, this entire thing is a closed thing.
Yes, sir.
Closed also, 2D at least we will have problem. 3D definitely no problem. It's a closed path. Closed from everywhere, 3D. Sphere
Yes.
is a three-dimensional closed. So no escape. Full symmetry, three-dimensional symmetry sphere will give. Ring
Yes, sir.
will give 2D symmetry.
Yes, sir.
So the integration of a physical quantity which is varying in a continuous way such that the initial vector and the final vector are the same. That means the function is reaching back to where it has come. Also
Yes.
vectorially in terms of 360 degree. If you remember in vectors, the summation of all the vectors along the polygon law, even if the polygon is not a regular polygon, is always 0. One of the reasons why, one of the byparts of this polygon law of vectors is also that the initial vector and the final vector have basically done a 360 degree rotation. Go here like this, like this, like this, like this. Whatever you do, the resultant change in your angle is 360 degree.
Yes, sir.
So this is just the one of the application of polygon law of vectors.
Yes, sir.
And the other thing is mathematical part is the continuous. The function is a continuous variation. It's not a discontinuous function. It's a continuous function, and it is moving in the 360 degree. The integration of all of it is actually 0. Are you getting my
Yes.
point? Or you
Yes.
can look at it this way. There are only electrostatics I want to understand. There are 10 points which are closer to it, which will have greater magnitude. So 10 into 100 is 1000. There are 100 points which are farther from it but lesser magnitude. 100 into 1000 is 100 into 10 is also 1000.
It will eventually give 0.
Are you getting my point?
Yes.
So less points, more magnitude, more points, less magnitude, eventually. Vectorially also, according to polygon law of vectors also, it is basically 0. I should get the mathematical, analytical solving also, I should get it as 0.
Yes, sir.
So RR gets cancelled, minus R, 2R minus 2R will also get cancelled. This is 0.
Yes, sir.
Is it clear?
Yes, sir.
Xerox. So here I want you to, after class, in the case 1, I want you to write a little bit of English with your own words. I'll give, yeah. So I'll give point wise over here. Polygon law. If you will not look at it after lecture immediately, after 2 days evaporation. Concept I discussed, that's the thing, right?
Yes, sir.
Concept analytical is there on board, but imagination part I discussed. One is polygon law applies over here. Second, I told what you have to write on, whatever you have understood, but make a proper English notes of it in your
Yes,
own
sir.
words. Second thing that I told is this is a continuous variation. And
360 degree.
360 degree, and I am integrating this entire story or
And
adding,
0.
yeah. So in
And
mathematics
also, yes, sir.
in mathematics also continuous integration of a function which comes to the same value from where it has begun is also 0. I'll show that to you.
And also the
Yeah, the less number of
less,
charges and
yes,
more
sir.
magnetic field. Third view that we have,
Magnetic field.
I already jumped into magnetic field. Okay, less number of charges, more electric field. More number of charges, less electric field. Less number of charges, more electric field. This way also you can look at it. And in this we are talking, it's a 3-dimensional story, so definitely it should be 0.
Yes, sir.
Very important statement which I am writing over here, which is important in terms of every exam. Electric field inside a hollow sphere is always 0.
So you wrote electric field inside the hollow sphere is
Always 0, and put 2 star marks to that statement. Case 2. What is case 2? If point P is outside the C, all we have to figure out is how well limits of Z is all that you are interested in.
Yes, sir.
What will this E net be? E net is equal to KQ by what was that? 4 R square R square. Am I right?
Yes, sir.
And I have an integral, and inside integral I have 1 minus
1 plus
1 plus.
R square minus capital R square by Z.
Okay, are you sure?
Yes, sir.
Check it once. I think it was minus, right?
Plus is there, sir.
Small r square minus capital R square. Yeah?
Yes, sir.
Divided by Z square and dz.
Yes, sir.
So for outside, all that we are interested in is limits.
Yes, sir.
And for limits, all we are interested in is geometry. So this is my sphere. This is my point outside. So what is Z? Z is this distance, right?
Yes, sir.
So closest point is going to be this point. Farthest point is going to be this point. So for the closest point, I will have small r minus capital R.
Yes, sir.
For the farthest point, I will have small r plus capital R.
Yes, sir.
So my integration will be from small r minus capital R to small r plus capital R. Okay. Is equal to K capital Q by 4 r square R square. See, the first integral dz is Z.
Yes, sir.
And integral dz by Z square is minus 1 by Z.
Yes, sir.
And which eventually we made it plus over here and we wrote it as r square minus r square by Z, right?
Yes, sir.
And limits from small r minus capital R to small r plus capital R. Now substitution of limits. Obviously this I should not get 0. Because all
Yes,
the
sir.
vectors are adding in one direction. I should have something, right?
Yes.
So KQ by 4 r square and upper limit minus lower limit. Small r will cancel, capital R will add. I'll have 2r. Can you see that?
Yes, sir.
This minus this. And this limits I will just write it for our understanding. Capital R minus r square divided by r plus r minus capital R square minus r square divided by small r minus capital R. Right?
Yes, sir.
I'll write this as plus and I'll write this as. Is this fine?
Yes, sir.
A square minus b square by a plus b. So this is a minus b. Capital R minus
Yes,
small r plus
Yes,
capital
sir.
R minus small r.
Yes, sir.
Right? Plus capital
Yes.
R plus small r. This is capital R minus small r and this entire thing is capital R plus small r.
Yes,
A
sir.
square minus b square divided by a minus b. Minus r
Yes.
plus r will cancel. This also will become 2r. This is 2r. Total 4r. KQ by 4r square into 4r. Is this correct?
Yes, sir.
4 will cancel. I will have r times r square.
Yes, sir.
Okay.
Yes, sir.
That's why I asked you, this is not r square. That is the reason I asked.
You got R square only.
This is not R square. Eventually this will get cancelled. We will get KQ by R square. In the initial derivation, check it once. There is no capital R square.
There is 4 pi R square.
Okay.
You cancelled R. No. R square only will go away, sir. From where R square you got again? Where should I send the picture?
No, we will do one thing after
I think
checking.
there should not be any R square only.
Okay, congratulations. In the
Yes, there should
derivation,
be only 1 R.
there should be only 1 R.
Yes, sir.
Okay, so eventually we will get it as KQ by R square, where smaller is basically the distance from the center. There is a easy derivation, conceptual and easy derivation for this, but not in over here in Gauss basically. Okay. Hi guys, I hope you enjoyed this session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.